Hello everybody and welcome back to another visual pattern challenge. Here's step 1, here's step 2, here's step 3 of our pattern. And your challenge today is to predict the fraction. The answer is going to be a fraction. So the fraction that is the shaded area out of this total box for step 4. If you can do that, can you predict that fraction for step 43? It's going to be a pretty crazy number. And can you write an equation that could predict that fraction for any step at all? So that's the challenge. If you'd like to accept this extremely difficult one today, pause the video and give it a shot. All right, so back to fractions. Well, this step 1 looks pretty simple, right? It's just half this region is shaded, so that would be half. And then it looks like they've taken the unshaded half and cut it in half. So, if we thought about this also being cut in half, this would be 3/4. So 3 out of the 4 areas are shaded. And it looks like they did the same thing here. So they took that unshaded area and they cut it in half. And, if we extended these lines for the same shapes, you could count up that there are 8. And there's just 1 unshaded part, 7 shaded parts. So that should be 7/8. So I would guess for step 4, they would cut this in half again. And we'd only have this part unshaded. And when you cut eighths in half, you get 16ths. So this should be 15/16 for step 4. That's my prediction. All right, so just looking at these numbers, are you seeing a pattern? We're not going to make a chart and subtract the differences. I think we can look at the numerators and the denominators and get some ideas from there. And actually, I'm going to start with the denominator. Because if I just list the denominators, I've got 2, 4, 8, 16, and this is the step 1, 2, 3, 4. So what pattern do you see there? These are actually powers of 2, right? 2 is 2 to the first power, 4 is 2 to the second, 8 is 2 to the third, and 16 is 2 to the fourth. So for our denominator, we could just call this 2 to the x, 2 to the step number power. And that should give us our denominator. What about our numerator? Can you see a pattern there? It's a little harder to see 1, 3, 7, 15. What is going on there? Well, it's really always just 1 less than the denominator, right? Because there's only 1 unshaded part of the fraction. So we could just write that as 2 to the x minus 1. And I think we're finished there. I mean, you could try plugging this in. 2 to the x minus 1, so 2 to the 1 minus 1 over 2 to the 1. That would be 2 minus 1, that's 1 on the top, over 2 to the first, that's 2 on the bottom, 1/2. Here we'd have 2 to the second minus 1 over 2 to the second, that's 4 minus 1, 3 over 4, and so on. So I think our equation here is y equals 2 to the x minus 1 over 2 to the x. Now, if you get this equation, finding step 43 is pretty easy. If it's hard to get there, it's pretty hard to get step 43 because this number is kind of ridiculous. So this is going to be 2 to the 43rd power minus 1 over 2 to the 43rd power. And when I type in 2 to the 43rd in my calculator, I get 8 trillion something. I'm going to try to write all this out. So on the bottom, 8,796,000,000,000, 93,022,208. So that's what I got for 2 to the 43rd. And then, of course, 2 to the 43rd minus 1 is just 8,796,000,000,000, 93,022,207. So that is the fraction of the shaded area. Well, how did that go for you? A pretty crazy answer, but I think we were able to get there because we saw the pattern, the exponential pattern in the denominator, and that the numerator was always just 1 less than the denominator. Well, let me know how that went for you. I'd be interested to hear. Thanks, everybody.